You have seen these images everywhere this week. You probably said, "Wow," and kept scrolling. Because hidden inside these photos are details that change how you see space forever. During this mission, astronauts traveled approximately 4,067 miles from the lunar surface and broke the record for the furthest distance humans have ever traveled from Earth. Over 7 hours observation window. The crew captured thousands of photographs, many of which are still being transmitted back to Earth. Media shows you the image, but skips the meanings. So here are 7 things you almost certainly missed. Those bright dots, they're not stars. In eclipse photographs taken during the flyby, the moon appears as a dark disk blocking the sun, surrounding by a glowing corona. When zooming into a surface of that dark disk, small bright specks become visible. These are not distant stars or reflections, they are dead pixels on the camera sensor. These pixels are damaged by cosmic radiation. The spacecraft operated outside Earth, magnetosphere, where high-energy particles are not reflected. These particles directly strike the camera sensor, permanently damaging individual pixel. Each bright dot represents a microscope point of failure because, by radiation exploiter, the cameras used, including Nikon D5, were exposed to conditions where radiation levels are significantly higher than on Earth. The same radiation reflects the human body. Although shielding reduces exposure, the visual artifacts captured in the image provide mirrorable evidence of this environment. You're not just seeing space, you're seeing how dangerous it is. There is a whole planet in this image that you cannot see. In the same eclipse image, a faint slew appears along one edge of the moon. This fact is known as Earthshine. It occurs when sun's light reflects off Earth's surface, ocean, cloud, and ice, and travel approximately 38,400 kilometers to the moon. The reflected light then illuminated part of lunar surface. In this specific image, art is not visible in the frame. However, the directions of illuminated edge allows scientists to infer Earth's position relative to the moon. This method relies on analyzing light directions and intensity. The phenomenon demonstrates that even when a glacial's body is not directly visible, it is pleasant, can still be detected through indirect lighting. The photo is hiding a second world. This image was impossible 50 years ago. One photograph from the mission shows that full disk of Earth at night, illuminated only by moonlight. This type of image was not achievable during the Apollo era. The difference lies in camera sensitivity. Apollo missions used Hasselblad cameras with film that had a maximum sensitivity of approximately ISO 160. In contrast, the Nikon D5 used on Artemis II can operate at ISO 51200, which is over 300 times more sensitive to the light. This increase allows the camera to capture extremely low light scene, such as the night side of Earth illuminated indirectly. It is completely new capability. Everyone is looking at Earth and missing the most important part. In the Whaley shares Arthur's image, the Arthur appears as recent above the lunar horizon. However, foreground contains significant geological information. A large crater dominates the scene, featuring a flat floor and central peaks. These peaks are formed during high-energy impacts. When a meteorite strikes the moon, on surface briefly behave like a fluid due to extreme heat and pressure. Material rebounds upward, forming central peaks before solidifying. This process is comparable to the droplet rising after an image impacts liquid. The structure visible in this crater are approximately 3.8 billion years old. The image was captured at 6:41 p.m. Eastern Time, just 3 times before the spacecraft passed behind the Moon. During this period, communication with Earth was lost for approximately 40 minutes, as radio signals cannot pass through solid lunar rock. During this interval, the crew had no contact with mission control, making it one of the most isolated moments experienced by humans. A geology textbook with humidity in the background, one of these craters made a Kamena drug tried. In close-up image of Oriental Basin, which spans nearly 600 miles, 2 small craters were identified by Creo for potential naming. One was proposed as Integrity, referencing the spacecraft call sign. The second crater was named Carroll by Commander Creo. The second crater was named Carroll by Commander Reed Wiseman in memory of his wife, who passed away in 2020. The crater is located near the boundary between Moon near and far size. This position allows it to be visible from Earth at certain time. The naming proposal was submitted to the International Astronomical Union, the organization responsible for official crystal naming. Approval process can take years. For example, a name proposed during Apollo 8 in 1968 was officially approved in 2017. Space exploration is human, not just scientists. The Moon is not smooth, not even close. During the final moment of eclipse, squints sunlight begin to reappear from behind the Moon. At this time, the edge of lunar disk become visible, irregular. This jagged appearance is caused by mountain and crater rims along the lunar surface. When backlight by sun, these features create silhouettes that reveal the Moon topography. From Earth, the Moon appears smooth due to distance and lighting condition. However, at a distance of approximately 4,067 miles, these surface variations become visible. The effect is produced by precise alignment between Sun, Moon, and spacecraft, demonstrating how orbital geometry influences visual perception. You are seeing the Moon as a real landscape. This is golden hour, but on the Moon, several images are captured along the terminator line, which separate the illuminating and dark regions of the Moon. At this boundary, sunlight strikes the surface at a low angle, creating long shadow and high contrast. On Earth, similar lighting occurring during sunrise and sunsets, commonly referred to so golden hour. However, due to the Moon's slow rotation, the terminator moves at approximately 10 miles per hour, allowing this lighting condition to persist for extended periods. In this image, the shadows stretch across crater floors and elevated terrains become more pronounced. These lighting conditions are valuable for scientific analysis, as they reveal surface features with greater clarity. The region photographer include areas near planned landing sites for future missions such as Artemis II. These photos are not just beautiful, they are reconnaissance. These were taken on phone. Some images from the missions were captured using smartphone, specifically device comparable to the modern flagship model. These represent the first smartphone used by Earth to orbit. While these images do not match the resolutions of professional cameras, their significance lies in accessibilities. The same type of device used in daily life was used to document deep space environment. The release of these images lead to widespread public tensions. NASA Administrator Jared Axman. The NASA Administrator Jared Isaacman reviewed a full image set and stated this is not AI. This statement addressed concerns regarding image authenticity in an era where synthetic media is common. Thousands of images and hours of 4K video remain stored on board the spacecraft. Data transmissions occur through a laser communication system capable of speed up to 260 megabytes per second, but priority is given to mission-critical data. The best image might still be on board. If you want to see what everyone else misses, subscribe for deeper breakdowns. I will be analyzing every new batch.